Hello, I hope you're doing fine. C++ has two real options for error handling for decades: exception or error codes. Exception are expensive and often banned outright in embedded and performance critical code. Error code are cheap but easy to ignore. Nothing stops you from forgetting to check one. C++23 finally gives a third option that's been standard in Rust and functional languages for years. STD expected. Let's see what it actually does and why it is worth switching to. Before I jump more into the video, I would like to mention that if you see a piece of code, try to write it on your own to see what kind of compile errors you are getting. And if you want to ask me, you can always write in the comment section. Let's jump. Consider a function that parses a string into an integer. Pretty simple, right? With exception, a mal from string throws, and now every caller either wraps a call in a try catch or silently propagates an exception up to the stack, which is fine until you are in a context where exceptions are disabled or too costly. With the error codes, you might run an int, stuff a sentinel value like -1 into it, or take an int reference as an output parameter out alongside a boolean success flag. Both works, but neither ties the error itself to the return value in a way the compiler can enforce. You can ignore the failure case entirely or the code compiles fine. So what you're seeing in your currently screen is like something like this, where you are trying to convert a string into an integer, and it can throw an error if it cannot be converted, like the sgs2i function doesn't work. So what is the solution here? The solution here is basically to use the std expected. The key difference from an error code, the compiler now knows there are two distinct states. First, the dot value which you can see in the if case versus the dot error which you can see in the else case are only meaningful in the respective state. So calling dot value on an error state throws std bat exception access, so mistake surface immediately instead of silently reading the garbage. Now let's move much more deeper into this and try to chain them. The real value shows up when you start chaining fallible operation. XTD expected gives you a monotonic operation and then or else transform like this. That let you compose a pipeline instead of nesting conditionally. So what you're seeing in your screen is that we are chaining the operation. So first, if any step fail, the error short circuits through the chain and you don't need an if check after every single call. This is the same shape as result chaining in Rust. It maps naturally onto the kind of validation pipeline you would otherwise write as a wall of nested F, which is never good. So this is making life much easier. Now, where this actually fits. This isn't a wholesale replacement for exception. Exception are still the right tool for truly exceptional rare failures where unwinding the stack is appropriate. Out of memory, programmer logic errors. STD expected is a expected failures. Things that are normal, anticipated outcome of calling a function. Parsing, validation, input output result. Anything where failure is just one of the valid answer, not a crisis. It's a strong fit for code base where exceptions are disabled entirely. A lot of embedded safety critical C++ falls into this category because you get a structured type error propagation without any exception machinery at all. Now, what we need to watch out for. A couple of practical notes. STD expected require a C++23 compliant standard library as of now. Support varies obviously through various compilers, so check your toolchain before committing it to production. So if your compiler supports C++17, STD expected won't work for you. And unlike exception, nothing forces a caller to check the result. If you ignore dot has value or and call dot value blindly, you get thrown exception on the error path anyway. So the discipline of checking is still on you, just made more visible by the time. Now, basically we close today's video by saying STD expected won't replace every error handling pattern in your code base. But for common cases like this function might fail in a normal way, it's a meaningfully better tool than what C++ had before. Next in the series, we will look further C++23 concepts. So subscribe to my channel and see you in the next video. Bye bye.